Hearty welcome to the video series on questions for revision. At this video we will see questions from application of derivatives. Reference material in all chapters of class 12 mathematics is available easily to all the students, but the students are not able to gather necessary help as they need detailed explanation, recollection of the concept required for the solutions, and the tips to do problems with slight changes and tips to reduce errors. The above needs of the students is taken care at this tutorial series. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 10 questions from selected topic is compiled, and the answers to the 10 questions are presented in PDF and video format. Students are hereby requested to start your revision by downloading the file with questions for revision. This material is only a supplementary to the revision strategies planned and executed by your experienced teacher. Let us move on to question number 1. The surface area of a sphere when its volume is increasing at the same rate as its radius is. Let us take S as the surface area, V as the volume and R as the radius. What is given? Volume is increasing at the same rate as its radius. Therefore, dV by dt is same as dr by dt. Formula for volume is 4 by 3 pi r cube for a sphere. Let us differentiate it with respect to t. Right hand side will become 4 by 3 pi into 3r square into dr by dt. dV by dt and dr by dt are equal. Therefore, you will get 1 is equal to 4 pi r square. For what is r square now? It is 1 upon 4 pi. Now, let us move on to finding the surface area. It is 4 pi r square. Substitute r square now. You will get the answer as 1. Therefore, the surface area of a sphere will be 1. Move on to question number 2. The function is given. We have to check out whether it is strictly increasing or decreasing in the given interval. Let us take the function now. Find the first derivative. I am getting 12 into sin square x minus sin x plus 1 into cos x. Now this sin square x minus sin x plus 1 can be written like sin x minus half the whole square minus 1 by 4 plus 1, which is 12 into sin x minus half the whole square plus 3 by 4 into cos x. Now let us analyze this f dash of x expressions. It is having two terms 12. It cannot be less than 0. Sin x minus half the whole square plus 3 by 4. That cannot be less than 0. Therefore, the value or the sign of f dash of x now 100% depends on the nature of cos x. The sign of f dash of x depends on cos x. Now all of you know that cos x is negative in the second interval, that is pi by 2 to pi. Therefore, f dash of x is less than 0 in pi by 2 to pi. Therefore, it is decreasing in pi by 2 to pi. Therefore, option B is correct. Question number 3. We have to find the function has a local maximum at x is equal to what? For that f of x, we are finding f dash of x and we are equating f dash of x to 0. We are getting the value at 3, 2. We have to check the value of f dash of 3 is greater than 0 and f dash of 2 is less than 0. For all of you know that based on the nature of the second derivative, we can check out maxima or minima. Therefore, f of x has local maximum at x is equal to 2 because f double dash of 2 is less than 0. Therefore, option D is correct. Question number, now this graph you are seeing, it is having a local maximum at x is equal to 2. Which of the following function are strictly decreasing in 0 to pi by 2? And sin x is increasing, cos 2x is decreasing in 0 to pi by 2, cos 3x is neither increasing nor decreasing, and tan x is strictly increasing. Now this can be found by finding their first derivative also, and the answer is cos 2x. But some of you may be having a doubt, sir, I want to see the graph of them. For I am showing you the graph. Sin x, it is strictly increasing in 0 to pi by 2. Cos 2x, you are seeing that it is decreasing from 0 to pi by 2. And cos 3x, it is both increasing and decreasing in 0 to pi by 2. That is why we have made a statement, neither increasing nor decreasing. Tan x, no need to tell you that its derivative is secant square x, therefore it cannot be less than 0, therefore it is always increasing. Well, move on to question number 5. Show that this function is increasing function. Whenever you want to show a function is a increasing function, you have to prove that the first derivative is greater than 0. Let us try to find the first derivative. Log of 1 plus x derivative is 1 upon 1 plus x. 2x upon 2 plus x, I am making use of quotient rule, simplified, and I am taking LCM. Now I have to simplify it totally. Taking LCM once again. Now simplifying the numerator, it will become x square upon 1 plus x into 2 plus x the whole square. Now check out, in the given question it is given that x is greater than minus 1. Check the question. Condition is x is greater than minus 1. Therefore, 1 plus x which is there in the denominator is always greater than 0. Because when you find this dy by dx, it is having 3 terms. X square cannot be less than 0. 2 plus x the whole square, that also cannot be less than 0 because always positive. Therefore, our nature of this dy by dx depends on 1 plus x only. Now we have proved that 1 plus x is greater than 0. Therefore, 1 plus x is greater than 0, x square is greater than 0, 2 plus x square is greater than 0. Therefore, dy by dx is a positive quantity always. Therefore, this function is an increasing function throughout the domain. We are seeing the graph of it. It is an increasing function from that throughout the domain, it is going up, going up, going up. For x greater than minus 1, check out. Below that it is going down, the graph is going down, but after minus 1 it goes up, up, up. Well, show that the function is decreasing for all the values of x. Tan inverse sin x plus cos x. We are finding the first derivative. It is cos x minus sin x upon 1 plus sin x plus cos x the whole square. And 1 plus sin x plus cos x the whole square is always greater than 0. No need to worry. Now we have to check out what will happen for cos x minus sin x in the interval pi by 4 to pi by 2. For that, let us recollect the table. For x from pi by 4 to pi by 2, what is the value of sin and cos? You are checking out there. Sin is 1 by root 2 and cos x is 1 by root 2. For pi by 6, root 3 by 2 and 1 by 2. For pi by 2, it is 1 and 0. But it is very clear that cos x is always less than sin x from pi by 4 to pi by 2. Cos x is less than sin x. For example, for pi by 6, it is root 3 by 2, but that is 1 by 2. Therefore, cos x minus sin x is less than 0 in the interval pi by 4 to pi by 2. Therefore, you are getting the idea that it is decreasing for all x belongs to pi by 4 to pi by 2. I am showing the graph also. This is the graph of tan inverse of sin x plus cos x. You are seeing from pi by 4 to pi by 2 it is just coming down. Therefore, it is decreasing. Question number 7. Find the maximum and minimum value of f of x is equal to sin 2x minus x in the interval minus pi by 2 to pi by 2. Always remember, the interval makes a lot of difference. They can give you from 0 to 2 pi, 0 to pi, minus pi to pi. So be careful with the intervals. I have taken f of x. Find f dash of x. And f dash of x has been simplified, equated to 0. You are getting cos 2x is equal to 1 by 2. And you have been given minus pi by 2 less than x less than pi by 2. Therefore, minus pi less than 2x less than pi. Therefore, the 2x values are minus pi by 3 and pi by 3. Be careful. Values of 2x are minus pi by 3 and pi by 3. But we need the value of x, not 2x. Okay. Therefore, x is minus pi by 6 and pi by 6. Therefore, this minus pi by 6 into pi by 6 lies between minus pi by 2 to pi by 2. Therefore, we have to consider these values to get the maxima and minima. Let me find what is f of minus pi by 2. It is pi by 2. Let me find what is f of minus pi by 6. It is minus root 3 by 2 plus pi by 6. And I am finding f of pi by 6. It is root 3 by 2 minus pi by 6. I am finding f of pi by 2. Simple, it is minus pi by 2. Let me compare these values now. Out of all the values, the absolute maximum is pi by 2 and the absolute minimum value is minus pi by 2. And you are seeing that in the graph of this function, and you are seeing that its maximum value is at minus pi by 2, minimum value is pi by 2. Sorry, at pi by 6, sorry. Minimum value is pi by 6. So anyway, you are seeing the graph is very clear here. Well, go to question number 8. Find the point on the curve which is nearest to the point. This is the application of derivatives problem. Px comma y be the point on the curve. Let d be the distance. I am using the distance formula. But when you use this function directly, there is a square root. Therefore, there is take f of x as d square. I am expanding it. But I want f of x in terms of x only. I know that x square is equal to 4y. Therefore, y is x square by 4. Expanded. And finally, I get f of x as x power 4 by 16 plus 2x plus 5. Differentiate. And simplified x cube by 4 plus 2. Equate it to 0. And I get the value of x cube as minus 8. All of you know that when x cube is minus 8, x is equal to minus 2. At x is equal to minus 2, I am checking the nature of f double dash of x. This is greater than 0. All of you know that the distance will be minimum. Second derivative at x is equal to minus 2 is greater than 0, therefore minima. Therefore, it is minimum. For when x is equal to minus 2, let us find what is y. Y is 1. Therefore, the point on the curve which is nearest to the point is minus 2 comma 1. Come on, let us see the graph of it. This is the graph. This is the function x square is equal to 4y upward parabola. The nearest point to minus 1 comma 2 is minus 2 comma 1. Let us move on to question from assertion and reasoning. Check out. Assertion is to be checked. Reason is to be also checked. We have to check whether the assertion is true or false. It is given that the function is increasing x minus sin x. Let us check. Let us find f dash of x 1 minus cos x. 1 minus cos x is greater than 0 as minus 1 is less than or equal to cos x less than or equal to 1. Therefore, it is a increasing function for all x belongs to R. Let us check out the reason. Assertion is true. Reason is a function is increasing if f dash of x is greater than 0. Yes, it is also true. And reason is used to get the assertion. Therefore, both A and R are true and R is the correct explanation of A. Now, this problem can be done by derivative also. I think I have used a derivative idea only. Go to question number 10. The maximum value of f of x is sin x cos x is half. That is assertion given. I am finding f of x and f of x is half sin 2x and sin 2x lies between minus 1 and 1. Therefore, half sin 2x lies between minus half to half. Therefore, maximum value is 1 by 2. Therefore, assertion is true. What is the reason given? A function f of x attains its local maximum when f double dash of a is 0. No local maximum will be attained when the second derivative is negative. Therefore, reason is false. Therefore, assertion is true, but reason is false. Thank you, friends.